Alright, so it is another day and I've been waiting all day for this moment because I'm really curious to find out what the measurements are of this crankshaft. So according to the bearings, it is 20 over, so it's been ground already once or twice, I don't know. But I want to find out if it is still good for 20 over bearings. So let's find that out. So I haven't looked at the manual. I didn't want to know what the measurements, what the spec is, so I can have a little bit more accurate measurements, you know what I mean? I'm gonna measure in multiple directions and in multiple positions, left to right in the bearing area, to make sure that they are not oval or tapered. Okay, it's pretty much the same here and here and the same here. So that's our measurement. So that's 2.2928. Okay. Number 3. Okay, so that's a good measurement for them. 2.27592 and then 2.922. Pretty consistent. So that's a good sign. Everything is within 6/10,000 on the journals. Let's check the pins now. On number 6 we have 1.8 and then we have 56.3. So the journals are within 6/10,000, but here on the pins I went and remeasured. I was hoping that I measured this one wrong, but it is 63 and this one is 53. And we even have 51. We have 12/10,000 of a difference between the smallest one and the biggest one. That's our range here, and here our range is 6/10,000. So anyways, we're gonna check in the manual and see what is the spec for the journals and the pins, and we will see how close are we. Because if we are somewhere in the middle here, we're gonna have some that are 6 less and some are 6 over, so we're gonna be fine. But if they need to be 51, all of them, for example, this one is gonna be too big for us. All right, so these are all the numbers, the journals, the pins on the crankshaft, and the pistons. Now for the pistons, I measured top and bottom. The important number is the top one. I just wanted to measure the bottom as well and see how even the pistons are worn, but we are just fine. So 61 to 78, 67 to 88. Everywhere we are almost 15 to 20 thou bigger at the bottom than at the top. That's normal. Pistons are tapered and oval, so when we measure, we always measure in this orientation across the pin, not parallel to the pin, of course. In this direction they are smaller, they are oval. If you look at it closely, they're oval, especially if you look that way. So anyways, I need to know this so we can compare to our cylinders and see what is our clearance between pistons and cylinder bore. And now I have the block here and we're gonna start measuring the cylinders. I purposely didn't take the spec yet. I don't want to know what the spec is. Unfortunately, I've recently measured another block, and for those of you who follow my channel know that I'm rebuilding another engine at the same time of the 74 TR6 at work. And since I've done it just 2 days ago, I still remember the exact spec for here, and that's 2.94. Let's see how much difference we have. But before that, actually, let's look at the cylinders closely now that we don't have pistons in them. Okay, so here is our whatever. Like I said, this is not a ridge. Like, first thing when you open a cylinder block is to look at this and see if there is ridge here where the rings stop. Normally when the rings wear the cylinder out, they create a ridge here. That tells you right away that this cylinder is already overworn. But here we don't have a ridge, it's just discoloration. So I don't see any heavy scratches or anything. Unfortunately, there's no cross hatching. If there was cross hatch still, I would say this has been done very recently. Anyways, we will see what the size is, and if they're close to the spec, we're gonna just hone them and buy standard size rings and assemble them as they are. I really hope that this is the case. Alright, so to measure the cylinders or the bore of the cylinders, we're gonna use this dial bore gauge, and this is how it works. It's a busy end. We drop this into the cylinder, and when this needle moves in and out, it also shows how much it moves in and out there. So what we do is we set this dial gauge in such way that when this shows 0, this is going to be a known measurement for us. And of course, this known measurement is going to be whatever we have as a spec for the cylinder, which is 2.9400 inches. And then anything bigger than that is going to show something like that. So with this, we're not measuring the whole distance. We are measuring the difference between our set number and what in actuality the cylinder bore is. And let me show you how we're going to set it to 2.9400. We're going to set our micrometer to this measurement, so that's 2.9. So that's 2.9, 25, 30, 35, 40. So that's exactly 2.9400, this measurement from here to here. So now we have to set our dial gauge to show 0 when it's here. And we're almost there, by the way. I'm going to put the micrometer on the vise very gently, because it's a precision measuring tool, so we don't want to screw it up, right? So we have to put it right in between those two. So now we have to find the narrowest distance here, because everything wider than the narrowest spot is diagonal. We don't want diagonals, we want perpendicular. So that's where our 0 is. Thing is, I'm not going to be able to do it like that. So there you go. So it goes to 0. As I'm shaking it up and down, it goes to 0, and then it goes up again. So 0 is our shortest distance. So that's it. Now we know that when it shows 0, it shows exactly 2.9400. And then whatever the distance here is, that's our difference. That's how much over 2.9400 we have. So let's go to the cylinder now. Alright, so now that we have our tool set to 2.94, let's see how wide our cylinder is. So how we measure is we drop it down and we try to position it perpendicular to the cylinder, of course, because if it is tilted like that, it's going to give us wider measurement, or if it's tilted like that, again, it's going to give us wider measurement. We're looking for the shortest measurement, which is going to be exactly perpendicular. So when we drop it down, So you see, wide, narrow, and then going wide again. So we're looking for the shortest one, the narrowest one, which for us here is 21 10,000ths, I would say. So the small increments here are 5 10,000ths of an inch or half a tau, and every other one is 1 tau. So we have 2 tau and a little bit more. So 21 10,000ths of an inch is this cylinder. This tells us that the difference between our set measurement and the true measurements of the cylinder is 21 10,000ths. So these 21 10,000ths we need to add to our set measurement, which is 2.9400. So now we know that this cylinder is exactly 2.9421 bore. So this is the true bore of this cylinder. But is that enough for us? No, it's not enough, because this cylinder, it might not be round anymore, it might be oval. So here it might be exact measurement, but here it might be bigger or smaller. We don't know that. So for this reason, we're gonna take 3 different positions. We're gonna measure, I call them first, second, and third position. And my first position is always across the block this way. That's my first position. Then I go 120 degrees clockwise, and that's my second position. I measure in this direction too. And then I measure 120 degrees counterclockwise from my first position. That's my third position. And we measure also how wide the cylinder is here. And then when we compare these 3 measurements, we can say if this cylinder is still round or it is out of round, or if it's oval already. And that's still not enough, because the cylinder might have been worn also in a taper shape like this, because sometimes the cylinders get worn more at the top than at the bottom. So we're gonna take one measurement at almost at the top of the cylinder, one somewhere in the middle, and one somewhere at the bottom of the cylinder. So top, center, and bottom. And again, for each depth, we're gonna measure the 3 different positions. And then we're gonna compare, for each position, we're gonna compare the measurement at top, the center, and the bottom. And that's gonna tell us if in this orientation, this cylinder is tapered. Then we're gonna compare the measurements at top, center, and bottom of the second position. And then we're gonna compare the top, center, and bottom of the third position. And that's gonna tell us if the cylinder is worn. So we're gonna take in total 9 different measurements of each cylinder. That's gonna give us pretty much a good picture of this cylinder. For this reason, I came up with a chart like this. I hope you can see it. Maybe I should take a marker. So we said that our set measurement for the gauge, for the dial gauge, is 2.9400. This is gonna be our top, our center, and our bottom. This is gonna be our first position, second, and third position. So let's take these measurements, and then we're gonna see how we're gonna analyze them. Top, position 1. I would say 26 tau. 26 10,000ths rather. So 0.0026. Then we set clockwise. Well, that's the same, 26. And third position is counterclockwise, and that's 21. And then we're gonna do the same at the center, somewhere, 21, 18, and 16. And at the bottom, that's 25, 19, and 19. Okay, so now that we have all these 9 measurements, let's analyze and see what information that gives you. At the top level of the cylinder, in positions 1, 2, and 3, we have these 3 measurements. So the smallest one is 21 10,000ths of an inch, the biggest one is 26 10,000ths of an inch. The difference between them is 5 10,000ths of an inch. At the top level, the cylinder bore is out of round by 5 10,000ths of an inch, which is totally acceptable, by the way. Here, the smallest one is 16, the biggest one is 21. So at the center we have out of round 5 10,000ths again. And here 19 to 25 at the bottom we have 6 10,000ths of an inch out of round. So our biggest out of round is what matters. So 006 is our overall out of round. Now let's check for taper. Our taper, we're gonna check top, center and bottom of the same position. It's position number 1. So here we have 21 to 26, that's 5 10,000ths of an inch of a taper here. Here we have from 18 to 26 is 8 10,000ths of an inch, and here we have from 16 to 21, that's 5 10,000ths of an inch. Our biggest taper is 8 10,000ths of an inch, which is totally acceptable too. And now for our overall measurement, we have to add the biggest number out of these to our set measurement of the gauge. The biggest one is 26 10,000ths of an inch. So our measurement max is 2.9426. So this is the information that we need for this cylinder. So we're going to compare it to the spec and we will see if that's acceptable. But we're going to do that for all the cylinders, and I already drew a chart here that is going to help me put everything together. And I'm just going to transfer all this here for first cylinder, and we're going to measure the other ones too. All right, so I measured everything. I calculated all the out of rounds, all the tapers. I put them in each corner here of each cylinder, and then I transferred them here on this paper. Unfortunately, I used this paper for this, so now it is pretty unreadable, but yeah, that's more clear. So I have first to 6 cylinder, and I have out of route, taper, and maximum measurement that I found on this cylinder. So if you see here, for cylinder 1, we have 6 out of round. I'm not really sure what the tolerances here are, but I am accepting everything up to 10, maybe 15 even sometimes, if it is only here and there. But here we are fine. We have 6 out of round and 8 taper. The total measurement of this cylinder is 2.9426, which means that it is 26 bigger than the spec. Now, in all the manuals, there's absolutely no wear limit. Nowhere they mention how much is the wear limit, so before you have to go and rebore the cylinders. Unofficially, everybody says that the wear limit is 0.1 millimeters. That equals 0.0039 inches. So 39 10,000ths of an inch, or almost 4 tau, is our wear limit. So here we're only 26 10,000ths of an inch bigger, or 2.6 tau. So we are still within the wear limit. We are at the top end, so I wouldn't recommend staying with the engine as is. I would recommend reboring it, but that's not the only reason, and we're gonna get to that later. So cylinder 2, we have 7 out of round, 4 taper, 26 bigger than the spec. So again, we are still within the wear limit. On cylinder 3, we are 9 tenths out of round, 8 tenths of taper, 29 10,000ths bigger than the spec, still within the tolerance. Here though, now we become bigger and bigger. Cylinder number 4 is 11 out of round, 7 taper, 31 bigger than the spec. So it's very close to the 39 limit. Here we're again 11, 6 and 29, again pretty close. And cylinder number 6 is what confirmed for sure that I have to rebore this block, because look at this, 15 out of round, 12 taper and 44 10 thousandths of an inch bigger than the spec. So it is already bigger than the wear limit, and it's so much bigger than all the other cylinders. I have to look at the compression, but I don't remember what cylinder number 6 was as a compression, but it is so much bigger than cylinder number 1, for example. So definitely this whole engine needs to be rebored to the next level, which is 20 thou. Yep, that's where we're going. And if you look here, that's just for your information, always the biggest number for each cylinder was in position 1 at the top. That's because always the cylinders get worn as a taper, so of course our biggest measurement is going to be somewhere at the top, and also because the piston is always pushing in this orientation, and it always wears the cylinder on this side and on this side. And believe me guys, I went back and I measured this one more time to make sure that I'm not wrong, and then I even went and I double checked my tool with the micrometer to make sure that I didn't drop it or something, but unfortunately it is what it is. So I'm gonna put all this information in my computer just in case, but the decision here is that the cylinders need to be rebored to plus 20. Oops, 0.020. I need them rebored to 2.9600. And that of course means that we need new pistons, so this we don't care about this measurement. Now let's look at the journals and the pins. Alright, so I have the Bentley manual here, and I was having a really hard time to find the crankshaft measurements, but I found them here. They're actually given us a data into one of the articles here, how to remove and replace the crankshaft, not in the general specification data. Anyways, this is what it says here. The journals need to be between 2.3110 and 2.3315. Definitely that's a typo because it can be such a big tolerance. This is almost this is like 20 thou difference. So I went to the metric here and I converted it back to imperial, and it turns out that this is not 3, this is 1. So I'm gonna correct it here. This is 2.3115, just for future reference. And the pin's diameter is 1.8750 to 1.8755. So this is our standard. Because this page became a mess, I'm just gonna say that our journals are between 2.2922 and 2.2928, and our pins are between 1.8551 and 1.8563. So based on the manual, our spec here is 2.3110 to 2.3115, and our spec here for the pins was 1.8750 to 1.8755. So according to the bearings that we had on the crankshaft, it's been ground by 0.0200. So that makes it come to 2.2900. Oops, 2910 actually, to 2.2915. So that should be our range, 2910 to 2915. Well, we are a little bit bigger. So the smallest journals are bigger by 0.0007, and the biggest journals are bigger by 0.0013. But it's good that they're bigger, they're not smaller. So I believe that we are good on the journals. And the same here, if we subtract 0.0200 from the spec, then we're gonna end up with this number, 1.8550 to 1.8555. 1.8550 to 1.8555. So our smallest journals are within the spec. They're smaller than the higher range, so we're fine. So some of the journals, let me see which ones. So we have only two. One that is 59, so that one is bigger by 5 thousandths, and this one is bigger by 8 tenths. Again, this is less than a thou. I will let it go. So our crank is perfect. So we're not gonna do anything with the crank. The crank is gonna go. We're just gonna buy new bearings. The cylinders, we're gonna have to rebore to 2.9600, which is 20 thou over, and that's it. So we're done with our measurements. I think it's enough. I'm sure Chef Tash's brain hurts again, so I'm not gonna do any more numbers. Let's put an end to this video here, and in the next one we're gonna start taking the head apart so we can have an idea about all the parts, and then we can order the parts, and as soon as they come we're gonna start assembling. And of course we're gonna have to machine the block. I already called a machine shop. They can do it within a week, so that's fantastic. So as soon as we get the parts and have the block back, we can start assembling and timing and all these fun things that we have to do with the engine. So thanks for watching, guys. Thanks for commenting and subscribing, and stay tuned for the next part of this project and maybe some other ones as well. Thanks for watching, guys. Bye.